Hey, it looks like we're live, so welcome back. Today I'm going to be starting a new project. It's not really a new one. It's very relevant to the past things I've been working on. So both the virtual machine and the Kano, the text editor that I've been working on, it's basically an extension of those. So it's the scripting language for Kano, and it's gonna be built on top of the virtual machine. So I'm gonna make it in the same the same project directory as virtual machine, Titanium virtual machine. That's what it's called. It's gonna be in that same directory until it's more mature, and then I'll move it out into its own thing. Yeah, so Kano scripts. That's what this one is gonna be called. So we have like an example of what it'll look like here. I was thinking we don't really need the main function because it's a scripting language, right? So it doesn't need that, right? So this is what I'm gonna be trying to compile today. So write hello world. That is the goal, and yeah, so it's gonna use the built-in native function, which can call to a syscall, right? That's what we're gonna do. That is the goal. Hello, how you doing? That's the goal, to make this compilable, hopefully today. At least get a decent amount done today. So to start, I'm going to get a string view. Let's see. Yeah, I'm gonna get a string view library because that makes it a lot better for working with strings. So I'll just download that one. Right here, yeah. So yeah, I'm gonna import that. It's just a header-only library. Been experimenting with Zig as a build system all day for C++. And how's that going? I've heard that Zig can be used as a build system like that. I haven't looked into it all, but it does sound pretty interesting. So how is it? I haven't used Zig at all, so I don't know anything about it. It does seem interesting though, and I would like to look into it at some point. Yeah, so it's gonna be a C file. So let's write a hello world. Just to try it out, and then we will actually Lex it in everything. So I'll make a build script as well. C, not C, dash main, dash extra, and that's probably it. Yeah, so I'll use probably a makefile later on, because I don't feel like writing it right now. But that should be good. So let's do today and build it. Let me actually this one will be for coding, and this one will be for compiling. So I'm just going to rename it so that it's clear. It's not bad. The build system is fun. The passing types between C++ and Zig is a pain because I like using the C++ standard library. Zig only knows C types. So your lovely unordered map, for example, is tricky to pass. Yeah. So it'd probably be a lot better using like using C then, right? A better experience. Yeah, I see what you mean. So how do you like get around passing it? Like, what do you have to do for that? And there we go. So we compile it. Yeah. So let's just let's see. No, I'm gonna use Kano phrase. May not see, and then let's go over here, and let me look in the v.h file. Let's see. So do we have something for opening? No, we do not. Been running C++ for about a year. Never written C before. Oh, okay. Interesting. So C++ before C. Getting around that is a problem for tomorrow. Okay, I see. Well, definitely let me know how that goes, because that seems like an interesting problem. All right, yeah. So we need to be able to load it to a thingy, right? So read file to view, and we're just gonna take a file name, and then so we'll open it. So file equals open file name for just reading, because that is all that we're doing right now. Okay, and then let's see. So we're gonna make sure to close it. Do it right. Close. And then all right. So fseek. How do we do that again? It's fseek. Fseek. So string. Okay, yeah. So the file, and then the offset is 0, and then seek n. Then seek set. We'll set it back to the beginning, and we can just get the length. So the length equals fl file. So that will get us the length, and we should be good there. Okay, so we have the length, and then we need to just basically allocate a string for it, and then we'll just return the string here. So we're gonna return it, right? Okay, and we want to star data equals we're gonna allocate it size of character times length. Okay, times len, and we don't need the null termination character, because we're using a string view, so we have the length, so we don't have to worry about that. And then we will just feed into data. Let's see, size of character. I think this is the order, and then len from file, and that should read all of the data into there. And then just return a string view, which is the dot data is going to be data, and dot len is going to be len. And that should be pretty much it. So we should be able to read the file to view. Kingdom.kingdom, that is what the file is called. And then we should be able to print the file. We need to actually assign one. So string view read equals that. Okay, we can just print this. So view print view log, and we'll add a new log as well. Alright, so I think that should pretty much work. So let's go here and let's try to build it. Okay, a lot of issues. So we need standard library std with and read file to view, so control, which is end of non-read function. Okay, view print. So I did that wrong. View print unclear. Okay, is it not called view? Oh yeah, I didn't include the I need view.h. Got to include that. That's pretty important actually. That is the header file. Oh heck. There we go. So that fixed all the issues, so we should be able to run this, and it does actually read it, and it prints an extra new one. So, but yeah, so it reads this. So now we need to tokenize it, right? So let's make a function. So we'll just tokenize. Maybe let's call it lex, right? This is going to return an array of tokens, and then we're going to parse the tokens. So we're going to lex the view, right? So we'll just pass a string v there. So this, I should probably even move this into the view.h file, because I think that would be helpful for like a lot of scenarios, but not for now. So yeah, this is going to return a token, which we don't have that yet. Token array, lex. Yeah, so lex, and it's going to take a string view, and this is just the data. And it doesn't need to be a pointer because it's not that large of a structure. Yeah, and we're not modifying it anyway, so we're just gonna read from it, and we're just gonna let's see. So we could use a couple of the built-in functions. They don't work very well though because I did not write them properly, and I need to go through and rewrite them. So I'll probably just make my own thing. So we're going to basically iterate over it, and while it is a word, we're gonna do something, and we're going to basically collect the word into a buffer, and that's going to be for the token, so we can figure out what it is, or if it's a number or something like that, or a string as well. It's going to be different depending on what it is. So you could probably look at just the first character. So if data, this I'll just call it view actually. Yeah, it makes more sense. So view dot data. So yeah, we're going to dereference it, so it'll be the first character. So let's do is digit first. If it is digit, then, well, actually, we don't have any digits in here, so I'm not going to worry about that yet. So let's do is word, right? And I'm going to make a custom function for that. Is word that. Then we're going to basically collect word. So is word. I'll put it up here. So it's going to return a boolean. So let's actually include std bool. I can type. Return a boolean. Let's see, is word. Yeah. No underscore, so it's similar to the C library. Is word. So actually we have two different things. We have start of word and word. Because the start of word, it has to be a character, right? So maybe actually, yeah. Maybe this could be is alpha instead. Because it can't start with like a number or something, because then it's a number. But is word, it could be a number. So I think that makes more sense actually. And yeah, so we just return. Yo, how you doing, Stan? Yeah, so we're gonna take a character, just a C, right? And then if C, well actually is alpha, C, or is digit, C, so it can be a digit as long as it's not the first one. Working on an evolution simulator. Good so far. Doing it on Rust. That sounds very cool. Yeah, I would definitely like to see that code when you are close to being finished. That would be very cool. I'd like to see how that would work. Or an underscore. Then we could actually simplify this. We can just return that, right? Pretty sure that would work. Pokemon evolution or real evolution? Yes, real. Real evolution. Very cool. That sounds super fun, actually. So if is alpha, then we need to check while it is a word, we're going to be collecting it to a buffer, right? So while is word, u.data, and we want to actually chop left. Do we have that in u.h? Left. We do not. So that's pretty helpful to have. So basically just iterates it by 1. So let's see. We don't have that. A lot of religious people believe in evolution now. Some of them don't, obviously, but still. Okay. So this is, yeah, chop left. So it's just gonna be a void, I think. Well, it could be an int if it fails. So u chop left. String u. And that's gonna be all that we need for there. So it's just gonna basically iterate the data and the size. So we'll put this at the bottom. Int view chop left. And so we'll set view.data ++.len ++, and then return view. So actually it's gonna return a new string, so that's what we're gonna return. Okay. So let's do if let's see. Yeah, if view.len is 0, then we want to return. Okay, interesting. What do we want to return in that case? Well, no, then we just don't want to do anything. So yeah, then we can just return view. So instead of this, we could do if view.len does not equal 0, maybe even just greater than 0. Then we'll do this. Oops, yeah, that could count. view.data ++, view.len ++. Okay, then return view. So that should work then. Yeah, so basically just iterate. Actually, this is -1, it's not ++. Yeah. Okay, so while is word. So we want to chop left here. Yeah, let's do it here. So u equals u chop left. So that will basically iterate it. So it'll go to the next character. And then while is word that, then we're going to keep chopping left. So u chop left view. And also, u.len is going to be 0 and that. Because obviously we don't want to go to the end. We don't want to go past the end, I think. Yes, that should basically collect it. We do need to collect it into some sort of a buffer. So we'll do that later. But first I want to actually create the token so that we know what that means. So type that struct token. So we have a few things that we need here. So we need a token type, right? This will be the type. And then we also need let's see, so we'll probably want a string with it. Or, well, so we have the type. I need to think what else. We're gonna need the location, so we'll make a type for that location. Maybe it can just be locked. Do we need anything else to go with it? That depends. For now we won't. So let's do type that enum. So these will be the token type. So we'll have TT, for now, we're just gonna have TT right. Well, actually, yeah, we'll just have TT right. Needs to be a comma. My screen got orange. So right is like a, oops, what happened? There's something else. And I don't know what happened. What? Okay, let's start over. I'm not sure what happened then. Okay, token type. Yes, we don't really want right. No, we do want right. So right, and this is, well, actually, I'm trying to think. So, what? Yeah, I had no idea what happened. It just kind of shuffled the file around. I don't know. I don't know if that was the thing with Kano or like, most negative what? Well, I've not had something happen like that before. I've had it where Kano, I fixed this, but it would delete like half the file from where the curse is at, basically. But I sort of understood what was going on there. But with that, I have no idea what would have caused that. Kind of funny though. Okay, for now it's called right, but later on it might need to be replaced with just like, not necessarily a function call, but like a native call. But for now we'll just have TT right, and then we'll have TT string. So that's all that we need right now. I believe. We need actually token type quote. It's double quote. Well, no. So yeah. Quote. Do we need quote or string? Yeah, probably string. So we'll handle the strings on the Lexing phase. Okay, I think that makes sense. Yeah, so if we encounter a quote, yeah. So I think that'll work. So we just need those two. And then we need a location. Yeah. So this is location. So we need basically size t row and size t column. So that is all that we need for location, right? And probably also the file. Yeah, I think that'll work. Because we want to know what file it comes from and the row and column of it. So I think that makes sense. Makes sense to do. So, we're gonna create a token here, right? So maybe we even want to separate this into a separate function. Is that what we want? Well, we'll handle it here, and then we'll worry about that later. So we're going to collect it into an array, right? So how do I want to handle that? Well, I'm just let's think. Maybe just word, right? It can just be like this, 128. So we probably won't have tokens greater than that, at least not now. In the future, probably we'll replace this with like a dynamic array allocated on the heap, but for now, this should be. Let's have size type word size, put right here, and we'll just append this here. So word size plus equals view. Like that. And then the same thing goes in here. Well, no, for the first one. There we go. All right. So that should basically create the word, and then we can check basically what type of thing. So we'll probably make a function for that. So create a token. So this is token, yeah. So we'll zero initialize it for now. So we don't really have the location, so we'll need to keep track of that. For now, I'm going to worry about the type. And then token.type equals token get type from a word, right? So from the word. So we can pass the word size as well, so that we don't need to null terminate or whatever. Yeah, we're just gonna basically if else over it. So let's do this. It's just gonna return a token type. Token get type. Well, it's not really token get type, it's really get token type, because we're not getting it from a token. Get token type, and yeah, it just takes a char star. So this is the sir, and then size the sir size. Okay. So I'm gonna rename this. Okay, token type. And let's see. Basically, if stir compare. So yeah, we need to compare the stir with the built-in function. So maybe we should even have an array of built-in functions, right? For now, we'll just do this, right? And then stir size equals 0. Then we'll return pt right. Okay, and that's really the only thing that we need to worry about right now in here, because we don't have anything else that we need to worry about tokenizing. So that's it. So otherwise, we're just gonna return tt none, and we'll add that here as the 0 equals 0. Okay. 89. So then, if token, oops, that token dot type equals 89, then probably will make a macro for it, but for now I will just exit. Sure. So we'll make like proper error reporting later. But then we can token. So we need to append this to the token array, right? So I'll probably make a this could probably even be a separate thing. So token array, like a dynamic array. Token should tell tokens or token array. It's equals. Let's do that. We're going to return a token array like that, and let's define the token array. So when you're here, type in struct token array. So token type. No, that's not what we need. We need the data. So token data. That is the array, right? And then we need the count and capacity. Okay, and then we're going to be able to use a function, which we don't have now, but I can copy it from here, this project. Use it in here. Yeah, right here. I'm using Vim because the copy paste works a lot better. As in, it actually works. See, so we'll just pop it in here, right there. And that should work. So, now we have DA append, so we'll be able to use that for this token array, right? Okay, so we'll just want to zero initialize. How does this work again? Count is there. Yeah, then we realloc, so that's all good. So I think we can do that. And then we can DA append to tokens. Tokens, we're gonna append the token. And that's gonna be, it'll be the first one in this case, but we could append many more and it can grow infinitely basically. And then we'll return tokens. Okay, so we don't handle a lot of stuff yet, but let's save this and it should work out. So let's actually make print tokens, right? It's gonna token array. Let's see, what's that? And then print token array tokens. So I just want to be able to iterate over all of them and then print the types, I suppose. So you don't want to put it here though. Put it up here. Void print token array. So it's gonna take a token array. And so for so that's 0, y is less than array.count, y plus plus. And we just print that. So I'll print it out as this for now. And probably also the index, right? So I, and then array dot data I dot type. So that's what I would like to put out. So let's see if this even compiles now. Does not compile. So yeah, so I need actually, this needs to be a pointer here in the DA append. So let's go ahead and do that. Look again. Okay. So get token type. For which is end of non-void function. Why is that? Wait, we don't have the assert either. Okay, so I will figure that out. But for now, because that's another macro, which is just, you know, so read file. What is, so get token type. It does not though, so I don't know what that's about. It's probably from this. So let me copy that now. So let's see, source .h. You can be assert macro as well, which I forgot about. Script .c, and I'll just put it right here. There we go. Okay, let's try to do it now. So that took care of some of them. Alright, string view from type int. Okay, so it doesn't like that. You should probably allocate this token actually on the heap. No, size of token to make sure yeah, we can actually use it from type token. Alright, actually it just creates a copy of it, so we don't need to do that. Yes, let's go back. Not quite, but... Okay, implicit declaration of function assert. We got that. Type. You chop. Oh shoot. Yeah, we need to update the u.8 because I said this as int, but it needs to be a string. Whoops, that was wrong. Whoops. String. I need to organize this better, but that should help with some of that. ttnon undeclared. Why is it undeclared? Do I need to cast it? I shouldn't. I have ttnon. Oh shoot. This needs to be. This is supposed to be an enum. That's a big issue. Enum. And also, where did the? Oh shoot! I got rid of that. That because I forgot to save it. Okay, let's start over. Go back here. That's the wrong file. Assert is right here, so grab that. There we go. Now that should work. Okay, that's a lot better. Data start capacity, we need to define that as well. Alright, data start capacity. So just do 16, that should be fine. That's just what it's gonna start at. Undefined reference to view chop left. Why is that? View chop left. I have that, right? Chop left. Why doesn't it like that? Not see, we have u.h. Why is that undefined? But string view is not undefined. Chocolate. Huh. What if I just have it like this? No, it's still not. Okay. Yeah, we have that. Let's define it here. So, oh shoot, I forgot to define, yeah, I know what's wrong. We need to define new implementation. That is what this is. I always forget about that. Okay. Now it works. Alright, so we can compile it, and if we run it, we get the 0th one, so that's the first one, right, is 1, which should be correct, so it is right. Yeah, TT right, so that is 1. So that worked. Probably can make a better way to print that, so we could have, like, type equals, and we should add probably a TT count here, like that. That will be the size of this TT count, and we'll have, right, and straight. And then that way we can print them all. Right? So instead of printing it out like this, we could print a string, which is types data. Okay. There we go. And then that should that's not right. Type. I'll call it types, I think that's better. There we go. That is not an integer. Oh yeah, I need the dot type. So there we go. There we go. I did that wrong. No, it just did not save. And that needs to be a comma. Okay, like that. Now it should compile. And if I run it, it prints out red. Okay, so that is perfect. So we parsed half of it already, or we lexed half of it already. So now we need to parse the string. I'm actually not gonna do the escape code right now, because I'll worry about that later. So let's just parse the string. So if we encounter a quote like this, then we need to collect it until the next quote. And if there is not one, and we get to the end of the file, then we need to report an error. So let's do that. So basically, in the lex, we can do else if u.data equals a quote like that. Then we're going to log data equals a quote. So let's do this stuff here. So we're gonna collect it the same way. Yeah, so do top left, do that, and then what does not equal rather. So we don't actually want to collect the first one, so we can get rid of that. We want to chop left because that will chop off the quote. Then we're going to repeatedly do this in here, like that. And then we'll also do word size plus plus. We actually do want to collect it while it is not that. Equals v.data. We also need to check that v.length is greater than 0. And then at the end, if v.length equals 0 and v.data is not equal to those, then we have to report an error, so we'll just exit it for now. For now, we'll do that. And then otherwise, we need to just basically collect it. So we do need a value in this, because if it's a string, it needs to have the actual value. So let's add that value. So we could probably do something with a union at some point. So this could probably be a string union, right? So a union based on the different types. For now, this is the only type that we have. So we'll have a string u value. Yeah, so we'll create a string u out of this. So let's see. So we'll do token equals 0. And then token.type equals bt string. We know that for sure. Token.value equals cster to view to cster. That's what it's called. That will create a c string out of that, but we need to set the null termination for it. So let's do word size equals the null termination character, and we should be able to pass that, and that will create a string view. And then we'll worry about allocation and all that stuff, so we don't have to worry about that. And then we will do a thing tokens. Okay. So I'm pretty sure that's about it. So obviously there's a lot of repetition here that could probably be factored out. But let's do this, and we also want to print the value, right? So that, and then value. So for now, it's just that. So let's actually do it like this. View print, view line. So we're gonna put the view arg here. Array data I dot. So that's only if it has value though, because otherwise it's just gonna be 0, so it won't print anything. So I think that's fine. Let's see. Expected string view. Oh shoot. Yeah, I did that the other way. So we need. Yeah, that was wrong. Okay, let me look in the line. There is one to convert. That. So that, yeah, we want to create a view. So we want that. So we need to worry about allocation. So I actually did that completely wrong. Okay. Yeah, it needs to be view create instead. View create word and word size. Except it's not allocated, so it's gonna not have the proper lifetime. So I'm going to take care of that in just a second. First, I need to take a quick break. So do about 3 minutes. I will be right back. Okay, I am back. So, whoops, I just closed the whole thing. That's my bad. There's a way to recover to my section, but I don't know how to do that. So, let's just go back here, Tmux again. Whoops, I'm not used to that. So, it's for code. Okay, let's start over. Not completely, but may not see. So, what do we need to do here? Yeah, we need to worry about allocating it. So, for this one, and probably should just do it for the rest of them as well. We'll make it a dynamic string, right? Dynamic stir. So that would just be a dynamic array, and then instead of this, we'll just do DA append in the same way. Yeah. So might be a little slower, but it's not that big of a deal. So we want word, and then we want the view.data. Okay. And we don't need this word size anymore. So instead of word size, you create from that. So we need word.data and word.count. Okay. Yeah, so that should pretty much take care of that. We need to add the DA append up here, as well as up here. And we can get rid of this, and we can replace it with this. So we need to actually create this dynamic stir, because we do not have that. So I'll define it up here, probably above all of these. Dynamic stir. So yeah, we need the data, then count, and capacity. So I'm naming it the same, because then we can use the DA append with it. That it works. Okay. Yeah, so then we don't have to worry about it going on a scope, but we do want to free it at the end, if it is not a string, right? So we can free word.data. Yeah, just like that. So let's go into script, build it. And word size is not clear. Yes, I forgot that we need to update this thing. So word.data and word.count. Okay, that's it, right? Not quite. So we set this null termination. We don't need that anymore. Okay, now we have a lot of issues. Word declared here. Word.data may be uninitialized. Yes, we need to just do that. There we go. Okay. Now it compiles, and let's run it. And not get all of it, so it cannot append this. Oh shoot, you know what it is? This goes one too far, doesn't it? Well maybe it shouldn't. Oh yeah, because we don't iterate through the entire of the view. So I forgot about that. View.len is greater than 0, we want to continuously do this, right? So we can get rid of this, and we want to indent all of this. And we can just close that there. Okay, and let's go here, build it now, and run it. And it runs forever. Okay, I think the issue is, because we do not actually, view top left at the end. So view top left, and we can actually set view equals that. So we want to be continuously chopping it, right? Okay, there we go. So we got write and string hello world. So we should be able to make as many of these as we want, right? So we could make write goodbye world, right? Something like that. And then if we run it, yeah, we got write string hello world, write string goodbye world. So it seems to be working properly. So we just want this one for now. The hello world. So we have the lexing working, at least for this very simple one. Again, there's some stuff that can be abstracted away, but I'm not going to worry about that at the moment. Okay, so that's pretty good. So we get this token array now. So I can probably commit this even. Let's go here. Let's see. So let's see. Actually, first of all, I need to add the get ignore. Okay, the get ignore. So let's do script slash name the script slash. That's probably all right. Okay. We'll just so main, yeah, the rest is fine. Let's yeah, let me commit it now. Implement lexing of hello script. Okay, I'll push that in. Okay, so that should be good then. Whoops, did not mean to even do that. Okay, So now we need to parse it, right, and create a syntax tree. So this is gonna return me a node, pointer to a node, and so this will be a parse. It can just be parse. It doesn't even be parse tokens, and we're gonna take a token array. And yeah, basically just going to iterate over it and create a syntax tree. So we need to define the syntax tree though. Equals parse. Okay. And then we're going to need something to print the tree as well, but we don't have that yet. So there's a few different things that are going to be here, right? So let's see. Oh, you know what? Maybe we should get the location working first, and then we will do that. So to do that, we need to probably take the start of it, and then we can subtract from that. We need to keep track of new lines as well. So let's see if u.data equals a new line. Then we want to plus, right? So we'll define lines outside of the loop. So size type lines equals 0. We'll start at 1 actually, because the line's gonna be 1, and then the column. Let's do row and column equals 1 as well. So it'll start at 1. Yeah, so we'll increment row plus. And then the column is just gonna be implemented or incremented each time, but we probably don't even need to do that. Instead, we could have a pointer to the start, right? So of u.data, no, that's not how you do it. Start equals that, and then we can subtract the current position of u.data from the start. And I think we have to add 1 to get it to be based on 1, because that's what you would expect, right? So when we create the token.location equals, we'll want it to be like this. So dot row equals row, and then dot column equals view.data minus start. Right, so we might have to do +1, but I'll look at that. And then dot file name obviously equals the file name, which we don't have, so we'll get to that. But that should be the location, so we should be able to do that for each one. So here as well. Okay, and then when we actually print them all, so I'm going to return 0 there, and then print token array token. So I want to print it, and this is just gonna return null for now, so that we don't get any. We're gonna get a warning of unused variable, but that's fine. Yeah, so we need to add it to the print token array. We want %zoo %zoo. We're gonna want the file name as well, but for now we will have that. So we don't need the index anymore. And we can have array array.data I dot location. It's just dot row, and then array.data I dot lock dot column. Okay, so let's try to build that. This is the wrong place. Okay, so unused variable root, that's okay. We don't have node, so that is a problem. So let's type def node. So it'll go after this. So this is for lexing stuff. Not this one though. For lexing. And then we'll have the stuff for nodes. Let's see, so parsing. Right? Parsing. Just that it's kind of clear what is what. This will be a node. And it'll just be that for now. Temporary. Okay, so expected that before that, token has no member named location, it's just locked. Okay. Put commas in here, is that what the issue is? Oh, so. And yeah, we have to get for both of them, I forgot. And not lock, yeah. Lock. Okay, save that, build it. Unused parameters, that's fine. Okay, so let's run it now. And 1, 5, and then 1, 19. So we really want this started with, I guess. So do that a bit different. Yeah, I think it makes more sense to be the start. So let's do this actually. So let's initialize the token up here. Token equals equals 0. So I want it to be 0 initialized. So we'll do that, and then we'll grab the lock and move it up here like that. And we'll put this down here as well. Yes, we get rid of this from here, as well as from here. And then it will be the start of it instead of the end. So run it now. 1, 0. So yeah, we need to do +1. Let's do that actually. +1. Because you would expect it to be 1 based, right? So like how it is here. This is the first character, right? Because that's more intuitive, I suppose. Alright, so let's run it now. So 1, 1 is right, and then 1, 7 is the start of the string. So if we look at the string, right, 7. So it is, yeah, character number 7 is where it starts. So that makes sense. That was kind of weird, but okay. Yeah, so that works. So now we are keeping track of the location, and that will be very useful for air handling, which we don't really do yet. Okay, so that's good. That is good. So now, something this leaves out is if there's a new line in the string, but I don't know that I want to support that. So, I'll probably check in here and then report it there. But for now, I'm not gonna worry about that because it's not a big deal. Just kind of an edge case, right? So let's try to actually do this. So the node, it's going to have a node type and then some sort of value, right? So the node type, right? It's going to be different, right? Because it's going to be more general, and then based on the type, we'll have a certain value of it, which is what we're going to call it, whatever. Yeah. So basically, I forgot to talk about what we're going to generate from. So this is going to expand into the assembly for the virtual machine that I have. So it's going to look like this. So I'll make kano.tasm. That's what it's going to generate. So it's going to look like this. So push through hello world, right? It's going to push that, and then it's also going to write it. So we need to push 1, which is standard out, right? And call native 1, which is write. So if I quit out of this, and I go into build/tasm and compile this, I think I did it all right. And then build/tire, that is the runtime, kano.tin, hello world. So it does actually print it. It doesn't print the new line, because I didn't add that. But yeah, so that's basically what it's going to compile into. I forgot to mention that, and that's kind of important. So eventually I might get rid of the assembly and instead do it directly to the bytecode, but for now I think it'll be easier to compile it to the assembly. So this is what we're trying to output. Yeah, I forgot to mention that, and it's kind of important. So that is the idea. So we have a type. So we're gonna have a few different types. So type that, node type. So we're going to have type native, right? So that is the native function. Like you saw, the write was native 1. So that's going to have an integer associated with it, right? And then we're going to have type string as well. That's the same as the token type, but that's fine. So type string, and that's going to have a string view value associated with it. Other than that, we don't need anything else yet. So we also need a node value though. So node value, and that's going to be a union. And then based on the type, you'll know which one it is. So it's the node value. So first of all, we're gonna need an int, right? So for native, and then that's probably fine. And then a string view for string. And then there will be other things, like expressions. That'll be like a whole struct and things like that. But we don't have that yet, so we don't have to worry about it. And I think that's all that we need. So now we just need a node next, and we need to define node in here. And I think we have to put struct here. And this probably makes sense to go at the top like that. So we have the next, the type, and the value for each one. Not next, but rather left and right. It's not a linked list, it is a tree. So it's just gonna be a binary tree for now. Might make it more complicated in the future as necessary, but for now, we can deal with that. So let's see if all of this compiles. It does, except for the comments I need to do there. Okay, so yeah, the rest of it compiles. We get some warnings, but that's okay. So, let's do print tree. Here. And we will define that next to the print tokens, and it's not going to do anything yet. Void print tree. Node root, and we're just going to void root, and that's it for now. Just so we don't get the unused. And then, yeah, so parse. So we're going to generate the tree here. So we're going to basically iterate over the tokens, right? So for I equals 0, while I is less than tokens.count, I plus plus. And let's see, so we need to basically switch over the token tokens.data I dot type. So case of pt right, you're going to do so, and that doesn't need to be capital. I don't know why I did that. It can't be capitalized. And then tt string, and then the other ones are going to be unreachable, right? So default. I don't think I want to use default because it's not going to give us a warning. So we'll use fall through for the rest, and we'll just assert, right? So this will be tp none, and then is tt count. So either of those is going to be an assert false, and we'll use the assert false, and then okay, something like that. Okay, so I think that's good. And depending on it, we're going to do a few different things. So if it is right, then we're gonna create the node. We're always gonna have a node. So let's actually initialize a node here. Equals size of node, right? We'll allocate it. It's gonna need to be allocated. So let's see. So we'll need the root node as well, and that will just be basically the main node. So node root equals now size of node, and this is what we're going to append to for the first one. But really, we want a current. So let's see. We're gonna need to use some some things to work on that. But for now, we'll just have that, and that's what we're gonna return, right? Return the root. And so this is the type. I guess we'll have like a root, like type root. Yeah, I think that'll work. 0, comma, and then it's not going to have a value, and that'll just be the root, right? And then maybe we'll have it for each function. We'll have a different root, you know. So then you'll traverse through each one of it, if that makes any sense. But root.type equals type root, and then that's it. So if we encounter a type root, then we know it's just the root node. Okay, so then for this, we need to set the node.type equals type native, and then node.value equals 1. So let's maybe we could define it, right? So this could be native right, and that could be a pound define up here. So native right is 1. And then we have some other ones as well. So like define native, I think open is 0. I don't remember exactly. It's the same. Well, actually, I can just look in here. Let's go like that. It's not in here. It's in the .c file. That's the wrong one. Tim.c. There we go. So let's look at native right, which is there. So open is the first one. So there. That's just to get an idea of what it is. We have open and right, which we're not going to use open yet. Yeah, because it's like a native syscall kind of thing, basically, which is why it's not wrapped in parentheses. Yeah, like if it was a function call, it would look like that. But this is a syscall, so we're using that. And in the future, once it's more mature, I'm going to define a function, which will be like print or whatever, which will be more general, because this will only take a string, and that's it. Yeah, so that's basically all that we need to do here. Then we need to basically put it to root left, right? Root left equals the arrow. And so obviously we can't quite just use root each time. We'll need like a current node. For now we can do that because it's simple enough. But then this is gonna expect a write. So maybe that's gonna be unreachable. And then we're going to expect token string right after that, right? So let's do expect token. We can just crash here if it fails. Expect token. So we're gonna pass the token array. Well, how do I want to do that? You know, maybe I don't. Maybe I just want to wall tokens.count, right? So instead do this. Wall tokens.count. Tokens.count is greater than 0. Then we're gonna do this. Tokens.data. Like that. So dereference it, you know? I think that'll work. This might need to be wrapped like that, though. Yeah, so we'll just get the first one this time, and then we will iterate the token, you know? So this will consume consume it, right? So expect token, it's gonna iterate it by 1 and then see what the token type is. So we'll pass the tokens and then as a pointer then, because we want to modify it. Expect tokens, and then I'll probably use variant arguments for this at some point where it could be multiple different kinds, but for now it can only be one, so we'll do that. pt string. So we'll do that, and then we'll make this expect token. So it probably won't return anything. Token array tokens, and yeah, so it's gonna be a pointer, so that did not work. Void expect token array tokens, and then we also need the token type, so I forgot that. Token type. Right. So if well, first of all we need to iterate it. So actually if tokens.count, we need to use arrow, token arrow count. If that is equals 0, then we need to just basically throw an error. So for now, I'm just going to exit, like how I am doing with the rest of them, with the rest of the errors. So we just exit with 1, right? And then we'll do tokens count minus, and tokens data plus. And maybe we should even free the previous token, but we might need to go back to it. Will we need to? I don't know. Trying to think. So would we want to do that? This is basically like chop left, right? But each token is allocated. No, it's not actually allocated, so we don't need to free it. Yeah, it's just on the stack, so we're good. Yeah, and it's just the whole array is allocated, so we're all good with that. Then we'll do if tokens. So we'll probably make like a tokens chop left kind of thing, but for now, yeah. If tokens data, we reference it. That does not equal type, then we'll just exit 1. Okay, so that should take care of all the things. So we'll just do expect token, and then if it's not, it will crash. Yeah, and again, I will add error handling and stuff like that later. So now we should have a string, so we can set root right equal to node. So we're gonna make a new node. Yeah, so node. Right, so maybe we won't even do that, right? Now inside of node, so we'll allocate it. Maybe this can just go in here, you know? Like that. This will be left, and right. Root right equals right. Alright, so we need to set root type equals type string. And then root value equals we need to get the data dot value, and so that is the string. So once it's a union, we're gonna have to do dot as string or whatever, but for now that should be fine. I'm gonna have value, we need to do as string, right? And then this we're gonna need to do as native. So each native function has a corresponding value. That is right. So I think that's pretty much it. For this stuff. Okay, let's go back, build it, and we have some issues, so that is a pointer. So invalid operand. We need dot type. And then arrow type. Anti-row type. Okay, how does this? Tokens data 0. That's basically what I want to do, but why did that not work? Token data is a pointer. Okay. Yeah, let's do data 0 dot type. I need that. Okay, there, so that works. That's fine. Same thing. Did you mean node? Yes, that needs to be capital A. Okay. What else? Tokens data is a type, so 178 That's the switch data. It's 78. There we go. So I'll just do the same thing here. Tokens arrow data 0 type. There we go. And this is pointers. We do that for all of those, but it looks like we did. And this is not a pointer. This is a dot. Node type. Node undeclared. Yes, it is called left. Okay. Build that. Yeah, it's just name it. So not ads, but just name it, and then okay, almost there. Node undeclared. Yes, so same thing. It's the left. The last thing looks like it is 187. That needs to be an arrow. 187. There we go. Equals tokens data. Yeah, so I'll just do this here. Tokens data value. There we go. So it does compile. Assertion failed, unreachable. Okay. So we encountered that. Yeah, so now we need to actually consume the next token on each iteration of the loop. So let's do consume. Let's do token consume. Consume. And we'll just pass the token. And that will just basically iterate it. So like how we are doing here. Let's do void tokens consume. Like that. It's going to take a token array. And we'll do this basically. Well, first of all, we need to do this. That did not work. Okay, we need to check if tokens count equals 0, then we'll exit 1. Yes, that should be fine. Because we don't want to be consuming an node. So tokens count minus, and then tokens data plus plus. Okay, build that. Token consume. It's token consume. That okay, that's compile that. And we do so we're still printing the oh shoot. Yeah, we print the token array. So we want to actually print the tree. So we need to make that. So we'll recursively iterate over it, right? So we'll print the left first and then the right. We'll print the main, left, and right. Yeah. So print tree. So we need to if root. Let's just call this node actually. Because that'll be more accurate. If node equals node. We need to actually initialize them all with null. So we're gonna have to do that. So basically if node equals null, then we'll just return. Otherwise, we'll call tree node left and tree node right. Okay, so what we want to do is we need to print the types. So let's do the same thing that we did with this. So this will be token types, and then we'll have the node types as well. Node types. So that way we can actually print it. So this will be a root, native, and string. Okay, so that one actually works out the same. So we need to replace where we have types with token types. And then yeah, we need to print the tree. Let's go there. Yeah, so we need to print that. So that will be the type here, and then we'll also print the value. So the value could be a number of things, so we're gonna have to switch over that. So let's just let's print that for now. So node types, and we need the node value like that. So let's just print the type for now. And yes, I will go left and right. First of all, we need to initialize the nodes with left and right. So let's actually, instead of just allocating it like this, let's do equals create node. Yeah, we'll just pass the native in there, so the token type. I mean, do we want to pass the value? Yeah, we'll have the value, so let's pass the value as well. So native right, in this case, is what we're passing. So we can just get rid of this. And then the right will be initialized. Like that, and then we're going to pass the tokens.data0.value. So that's the string view. Actually, that's not going to quite work, is it? For the value, because it's going to be union. Yeah, so let's not pass the value, just the type. I think it's fine. So value equals native right, and we can get rid of this. Okay, so instead of type native here, though, we want type string. Okay. So create node, and then up here, we're going to want create node as well. So this will allocate a node. So create node, type root. Okay, so create node is going to be this, and that's going to return just a node pointer. Create node. It's going to take a node type. So we'll do node equals malloc inside of node. And then node left equals node. And node right equals node. And node equals 0. Can I do that? I don't know if I can. I'll see if I can. Otherwise it's fine. And then node type equals type, and then just return node. Okay, so let's see if any of that compiles. We have a lot of issues. So my subscript is not an integer. Yeah, node value is not that. We want the node type. So tree right here. So yeah, we want node type, not that. Because type is always going to be an integer. Expected that, but for node. So 186. Forgot I sent code. Fine. Yeah, it doesn't like that, so that's fine. I think that is fine to not be initialized. I don't think it's a big deal. Node value. Yes, we need to do value dot as dot name, like that. All right, left. Why do I have more than one left? Oh yes, okay, because this needs to be right. Go. Okay, so it compiles. There is one issue though that I realized. This needs type count, and we need to use that here instead of this. Right. Okay, should still compile though. Okay, it's not because comma. Okay, so it does compile. Let's run it, and it doesn't print anything. The tree should. It's null. Let's print random stuff. Does it equal null? Is that? No, it doesn't print anything. So it doesn't call print tree. So, oh, we must be exiting the form. And then echo that. 1, yeah. So I think what the issue is when we do token consume, I actually want to call it here. Or not here, but, where is it? Can expect token. Yeah, we need to do token consume. And pass the, I forgot about that. Build it and run it. Okay, so root native string. Okay, so we have the tree there. It doesn't really look like a tree. So we need, like the left and right. So we'll probably want to pass the depth. I really want to worry about that. I want to think. So, I don't know that I want to prettify it, but basically, this is the left. We can tell because it printed first. Left and then right is string. So I'm pretty sure we have the whole thing. Now we can switch over the type. And then case type native, we can print the actual type of it. So I print that. It is just an integer. Is that right? Yeah. And we just want to print node value dot as dot native value, and then break, and then case type string. We can print it as a string view, something like that. View print view1. View arg node value dot string and break echo, and then the default we will just break because you don't need to print anything else. So do that. Run it. Huh. That did not seem to have worked. The string did not work. Why did it not? It tried to. It just printed the new line though. So we did something wrong. Value of that. The string is a string view, right? yeah, string view. So it should be set to that, and this is a string view. We set it in there because when we print it, we actually get it. So we just don't get it here. So maybe I should print it down here. Print at we print one view art root value dot string. I think that compile guys, and we get hello world there, so it's fine there. Why does it not work when we try to print tree? Did I mess something up? We print view art known value dot string stir. Yeah, so we do get stir. So the no value did not work. Value dot string. That is that's quite concerning. Get rid of the line here and just put like a okay. You are. So it's gotta be in the parsing, right? Let's put in here. So we know it's the third one. So let's do node test equals root right. So that's what it is. It's not an array. It's a tree. And let's try to print it, right? So we print you are test test value dot string. Like that. It doesn't work there either. It's just empty. So is it not allocated properly? Here's the string. Total value is word create with that. View create rather. So that should be fun, and it's allocated because this is an array allocated on the heap. So I don't care what the issue is. Open consume. I don't think it's not exiting with any code, so that's not it. But if I take this same one, and I put it in here, then it works fine, right? Except we need to use root right. No, it doesn't work. Oh, what? So I did something wrong. Oh, shoot. I see what the issue is. That needs to be right. Okay. That's what it was. I was setting it to the root, setting value that, and not the right. That's my bad. I don't want to set it right, though. I just want to set it right. Okay. Now we should be good. There we go. Okay, so we have the root. Which we don't print a new line for, so we need to actually do that. So let's do default, we'll just print a new line. That is clear what's going on. Completely messed that up. Okay, build that, run it. Root, so we have the root one, the left is native, which was 1, which is native right. And the right is string, which is hello world. So that's pretty much what we need to do there. So obviously, we can't parse any more than one thing because it just overwrites it, because that's what the root is. So we need to have like a current node, and then we'll basically iterate through that. So how do I want to handle that? Root left, you know, trying to think. So should we have the native call has arguments, right? Because each one is going to have a few different arguments. Like if we look here, and it's all gone, okay. Tim.c native whatever, right? Here. They all have some sort of argument. So like, well, time doesn't. Exit does. That has an integer. String compare, that has 2 strings. So they're all going to have arguments. I'm not going to implement all of those native calls, because like string compare can be implemented on its own, but like exit and stuff will. So maybe instead we could have that. I'm trying to think, like building the tree with just a limited left and right, it's going to be a lot harder to do that. You know, it's like the trees need to get more complex, kind of. So maybe we need another struct. And at the end of each thing, we're just going to automatically insert like maybe an exit function call. I think that, or maybe a halt. Should it be halt or exit? Exit's basically a halt, or halt is basically exit. So I'm not sure, but we'll think about that. But this will be a native call, right? So a call to a native function. And it's going to have a list of arguments. So, whoops, arguments. Let's see. Should it be like that, you know? Or should it be another dynamic array? Maybe let's do this, and we'll just limit it to like 8 or something. And we're also going to need to define the args, the arg struct. And then we'll probably have the type as well. So this is going to be the type. It's always going to be an integer. And then we can actually update this union. So the node value, it's not going to just be a string, but it would be a native call. That's going to be native call. Native, like that. And that's all that we'll have for now. You know what I'm saying? So we won't have a type string. But we'll have type. So that's really all that we have. It's just one native call, and then it has all of its arguments, you know? And we could probably reuse the args for that. But the arg is going to have different types, right? So arg. That's going to have the arg type and arg value. So arg type. Which that could probably be, yeah, this could be the general type used for different things. Like once we're defining variables and stuff, we could probably use this as well. So maybe it should just be arg type, since it's basically a variable. It just could be like a literal variable, you know? So maybe we'll use that, so it can be more general later. And then we need the var value. Let's define those there. Var type, and then this is going to be an email entity. And then this will be a struct. No, it'll be a union. That's what I meant. So union. So in this case, we'll have the string view and string matter. And then we'll have more stuff, you know. So we'll have integers when we have integers and things like that. So like when we call exit, we're gonna have that. So yeah, we'll not worry about that yet. So we'll have var. I don't want to call it var string, right? And then that's it for now, since that's the only type that we have. So then we're gonna have to define this a lot differently when we're actually building it. So we'll need to consume this, right? So we create this. We create a node, and it's gonna be a type native, and then dot value dot native is gonna be a bit more complex than this. So what we're gonna have to do is expect this. We already know that we are generating a native form. So we expect it to be a string, and then we need to set native equal to a native. So let's get rid of that. We're gonna create an arg. So this one just has one arg, so we can create it like this. Arg equals, how is it built again? So arg, let's go back to that. So the type is gonna be a string, and the value is gonna be the value of the string. So that type equals our string, and then dot value. I like it actually like this, so let's do that. Value equals tokens.data is 0. Dot value, just like that. Okay. So we have the arg that, and then want to set we need to create the native. So let's look at that again. So node, yeah, so native call. So we need the type and then the single arg. So we should probably have an arg count as well. And now this is making me think, it should probably just be a dynamic array, you know? It's like so many args, you know, and we'll have arg data and size to the capacity. Yes, and then we'll use that here, args. Then we aren't as limited, you know? So args. So we create an argument, and then we'll append this to the native. So let's make a native call equals 0. So 0 initialize it. And we'll just data append to call dot args, a single arg. And then we need to set call dot type equals native, what's it called? Native right, yeah. That makes sense. What is with all this white space? Native right. Okay. So type is that, and then native right, and we set root left equal to that. And we don't need this, and we don't need this. We don't need any of that. Yes, this will be on the left, and then the right will generate that. So, I'm trying to think. Yes, we pretty much will just at the end set root right equal to a halt. Hey Alvaz, how you doing? So now I'm just gonna do that. Root left equals left, okay, and that should be pretty much it. So let's see if that compiles. So we have quite a few issues. So 69, nice. This is a comma. Yes, now that does work. So 147. Node value dot native. So we don't really want to print it like that. We can get rid of this now. What we want to do is we want to print the. How is it going? It's going quite well. Basically, I'm working on a scripting language for Kano, as I've been sort of working on before. I'm just starting it, and I'm building on top of the virtual machine that I've been working on as well. So it's been pretty fun, and it's going quite well. So .native dot type. So I want to print that, and then for now, it's going to print the string. You'll print the new line here. Load value dot native, I guess dot value, is that what it is? Dot string. So we'll do this. WebSocket based paint, really? So how does that work? I would definitely like to hear more about that. So type in, yes, let's do that. Oops. Okay, type string, it's we don't have a type string anymore. Okay, native call has no minimum value. What is it called? Native call. Let's see. Native call what? Args. Okay. Dot args 0 dot data. Okay. Native right. Yeah, let's go back here. Print tree. This. Yeah. Okay. So native args 0 dot string. Args dot data 0. You paint and use the HTMX and go to communicate, exchange the canvas element. Ooh, that sounds pretty cool. Okay, so you use like HTML canvas kind of thing. Dot value. Is that where the value is? Oh yeah, this is the UR like that. Build the server-side stuff, not gonna lie. Front end in Plain.js is very underrated. Yeah, I've done a little bit of that. And I mean, I prefer it to like React and stuff. Yeah, especially like for more simple things, you don't need like extensive libraries and stuff. That needs to be different. like that. Very unnecessary, yes. Setting braces around initialize. So it doesn't want this. I don't have to do this. I don't know. Okay, so let's run and seg fault. Nice. So let's see, why did that happen? Obviously, there's a few things here. So we have the native call that we initialize. We append that. Oh, we don't set the args. So let's set oh, we do. So call.args. We append the arg. Is lit. I've not heard of that one. Yeah, yes, is that what it's called? This? Ooh. Yeah, I haven't heard of this. I'm not, not into web development. Fast web. Yes. Let's see. Custom element? Yeah. So I don't, know enough about it to know if this is good or not. But yeah. Cool. I might look into it. Probably not, because, I'm not into web development. But cool, I've not heard of it before. Web components was basically creating HTML tags. Nice. So it's one of printing. Go to there. So we can print the type, and then when we get to type native, not print that. Native.type, so we should have that. Did we still create it? So it's as close to plain JS as possible, but it's way cleaner. Nice. Very nice. If I was into web development, I would definitely look into that. But I like anything that's, trying to make the web better. Because it kind of sucks, not gonna lie. So we can only print the root, and then it fails. Why is that? Nice. The worst part of web stuff is by far CSS, not JS. Yeah, I'm not a big fan of CSS. And I was never good at it, so I be part of it. The tree. Right, how many ones did we get? One. Okay, so it's not there. So it prints the new line. We see that happened. Then it tries to print the let, but then it seg faults. So are we not setting it properly? Root let equals let. Root let is already null, so we don't need to set this, but we're going to set it to an exit syscall. That's not what the issue is. Let's see. So we expect token string, initialize the call, and we set the first arg to that. We don't get into this point. From there after, let's see. So we don't get past this point. So what is this? Okay, so we print that, but then it fails before we get it. Why is that? That is strange. Okay, so it doesn't. It just it's getting overwritten with the seg fault. So we do get here. But then we call node let and it fails. So node left, what does it look like? Let's look at the node, right? So the node contains a left and a right, of course, and then a type and a value. So node value is native, right? That's all that we have right now. And then node type could be any one of these, but it's going to be type native. So why does it fail? All right, let's see if we append the properties. Let's print the first arm, right? We print within one. It's been 8 hours on a behavior bug, and the error was in the most dumb place imaginable, which I didn't even consider. What was it? What was the error? The dumb place. I've had that a few times for sure. Zero. I did that. No. So do we not get it in here? Not okay. Do we not get to this one? Oh shoot, so it must not have saved. Oh, the arm.data. That's what it is. There we go, save it. Arm has no member named data. Oh shoot, so we need to do zero dot string. There's no dot value dot string. Okay, it's a little convoluted. Okay, run it, and we do get hello world there. So that is appended property. We set root left equal to left, which is created here. Let's just call it node. And then yeah, then we break out of this, and we consume the next token, which already got consumed. So it should be fine there. Maybe I should do GGB. So let's modify this, and let's just add GGBB2. Take a look at that. And GGB./8. And run. So we'll next, and we'll just next. And then we'll go into the print tree, right? Step here. So next. And let's actually print node left. Print node left type native. Okay, so we have that. So we can skip through this. Print new line. Print script. This is a little broken. Hang on. Okay. Then we step into there. Let's see. So node equals no return. It is not. Do that, and it did not print the type. Why did it not do that? Running the LSP server plus client and the diagnosis were never cleared, and I thought the bug was related to misusing of APIs of the client written in TypeScript. The actual reason is that errors were stored in a static variable on the Rust side. Okay, I see. Classic Rust, right? Okay. What is this? Alright, so it's simple, it's there. Resulting behavior that acts like the LSP is not clearing them. Huh. Just forgot that you need to clear it. Bruh. Okay. So an LSP. I don't know how those work exactly. Haven't looked into it yet. How is that though? Like building it. Alright, so it's set faulted there, but it didn't print anything. Alright, let's start over. Let's break on tree this time. Okay, then over here. It's a disaster. Set variable and errors were just accumulating. Disaster. So, did you manage to get it fixed or not yet? Step into there. Print node type. Print node types. Node type. Native. Okay, so why doesn't it print that? I don't get that. It should print that. You fixed it. Okay, good, good, good. Zero. Why is that? That is not right. Let's print node value dot native dot args dot data. Node value dot native dot arg dot data is 0. Cannot access that. Okay. Is this normal for TS? I don't know. Never used TypeScript. What the heck? Bruh. So an interface. Yeah, I don't really get what's going on here. That is interesting for sure. Okay, systems okay. So let's see, what is wrong? You put it here. Save a function for each number of input arguments. Is that what it was? Oh, I see. Is that required? You have to do it like that? Using TS for a week only for this project. So you've never used it before that? What does it look like? I'm already there. Whoops. Then it can be that. Okay. Malik 7000 followed. Very cool. Thank you. Oh, that's the VS Code API. Really? You did not. Oh. Okay, that is interesting. Okay, so this is causing a problem. Not print it. Can't access that data. So did the DA append not work? DA append, call args. Oh, we don't set the call. Yeah, we have to set, node, node native dot. What is it? Let me look at it. I forgot how it looks. Node value dot native. Yeah, that's what it is. Value dot native equals well, dot call equals call. It's just it needs a call, so we can do that. So yeah, there we go. So that's what the issue was, isn't it? Yeah. I forgot to actually set the variable. Okay, now it should be able to print it. If I build this and run it, it still doesn't work. Oh. Well, type equals that. Depending the args. Go here and let's try to print node value dot native dot args dot data. Can we do that? Yes. Okay, there we go. Now it works. It must not have saved before. Okay. Yeah, so now it prints it out. I just didn't save properly. So we can go to that. So, yes. If I write this again, go here, build it, run it. There we go. So we get the root, and then we get the native with that. So we need to set the right node equal to, just an exit syscall, I think is fine. So let's make that. So let's make native call. It's still gonna be a native call, but it's not gonna have a value. No, we'll have value. It's just an integer. And just exit with 0 by default. So, type native, so we still have that. Still a native call. Arg, yeah, so the arg can be, it could be an int. We shouldn't call it int, probably. Sure. Var type, var, and then the native call, the type, yeah, so the type is gonna be, what is it? I think it's 60 or something like that. Yeah, it is 60. Okay, so it's gonna call the 60 exit, 60 call. So we set root right equals create name, type native, so we'll create it, and then we'll set root right Leo LDev. I'm not sure how exactly to pronounce that, but just follow. Thank you, appreciate that. Okay, root right dot native equals. All right, let's actually create a call. I think that'll be easy. Native call equals 0, so we're in the same way. And then we want to set arg equals message to an arg type equals var int, and then dot value equals just 60, like that. Okay, I think that worked. And then we can just va append to the call.args, and then we want to set native equal to call, and root right equals. We already set it. Okay, yeah, so we're good. So let's build that, and it did not work. It's not like that. Root right is to be an arrow. Okay, so missing braces around initializer twice. Alright, actually, if you do this like r dot value dot integer equals 6, I think I can do that. That'll look better. Flag mode has no member named native. Value. Yes. Okay, so run that. And we got native 0. Why is it? Oh yeah, because can't. Well, no, we didn't set the type. Yeah, the type needs to be 60. And the exit code is gonna be 0. So that's what we want. So we need to set root right value. Make a call. We need to set the call type. So call.type equals, what's it called? Native exit. So we need to create that. Define native exit 60. So this card be an unknown as well. We'll do that, and then we need to actually switch over the type as well in here when we're printing it out, right? So yeah, it's already getting pretty long. Alright, it's not too long. Print tree. Never done that. Tree. Yes, we just want to switch node value native type. Then case var string, we will print this. Case var int, we will print it as an integer. So print that with a new line. Node value dot native dot args data 0 value dot string. So we should probably loop over it as well instead of doing it like this. Okay, but let's try that, and then we'll have to put it here as well. Alright, so build it. Issue that is string. Yeah, so we want it value dot int. Well, integer. Okay, build it now. And that did not work. What is this? What is that we're thinking? Oh yeah, because we still trying to check that. What? This did not work. What's that about? I'm trying to print that as an integer. Why is this? Mm. One is the type, so it's a right. Oh shoot, that's not what we want to iterate. We want the let's see, what is it stored? Is it in the, yeah, it's args data 0 dot type. That's the one. Yeah, okay, there we go. Now it works. Yeah, because before we were switching over this type, which was just what we're calling, so it was like way out of bounds and things like that. So now it actually works. So yeah, so this would be an exit syscall with 0. This would be a write syscall with hello world, and we don't have the length, but we don't need that because the way it works is it basically just gets the length because it's stored in the program, so we don't need to actually pass the length. Okay, so that's gonna be good for the parsing for now. So let's try to actually compile it, which shouldn't be too difficult, and then yeah, and then we'll try to make it more general. Where, well, actually that'll probably be the end of this stream. The next stream we'll try to make it more general and get some more things, right? Because this right now, you can only have one function. So actually I will commit it to this. So, what's that? Okay, so let's try that out. So let's make void compile maybe generate, right? And this is going to take a node, right? So we're going to basically traverse the tree, and based on what we encounter, we'll just generate the code for it, right? So when we encounter a write, we're going to, yeah, going to need to take the string value of it and things like that. So let's actually switch node type, right? Node type, and then case it's type right, great. And then otherwise, any other case, we're for now we're just going to assert. No, I'm not going to assert anything. I'm just going to break because I don't think we need to do anything else with the rest of it. Then we'll call generate on node right and generate on node right. So right now I'm just going to print it to the standard out, right? It's not type right actually, it's type native. So what we're going to do is we're going to look at the function call type, or the native call type rather. And then we're going to do different stuff based on that. So let's switch over the node. Let's see, it's node value native type. Right. So based on that. So actually I set it directly to 60 somewhere, I think. No, I didn't. Okay. So we'll do case native right, and we're gonna do stuff in there. And case native exit, we're going to do some other stuff, similar stuff, but not exactly the same. And then default, we're just gonna assert false because we shouldn't have any other ones here. Okay, so let's try that. And then, so native right. So we're going to need to take the string value, which is gonna be the argument. So we should only have one argument. So maybe if the argument count is greater than that, well, let's just assert that, let's do node. Let's also do if node equals node, then return. We'll make sure we do that. Node value dot native dot arg dot count equals 1. So it should only be 1. And we'll do too many, and that can be asserted because it means I messed up somewhere, not the user. Okay. Otherwise, we should have a string. So if node value dot native dot args dot data 0 dot type does not equal string, then we're going to use exit with 1. So exit 1. That's it. Again, we'll do errors later. Okay, then, so we know that we have a string. So we need to actually push string, right? So we need to push str. So this is going to be the code that we're actually generating real code. And then we're going to want the string here. So do is, did you finish any languages / compilers before? So I wrote, there's a few different things that I've done. So I wrote one a while ago. This is like my first one. It's very bad and it doesn't really work, but it's called named Langs. This was a couple months ago, like 5 or 6 or whatever. 5 months ago, yeah. So I got this. I don't actually have the syntax here, but I think it's an example. Examples, yeah. So like FizzBuzz. I got that one. So you can do this. This was that. And it compiled to assembly. And then the other thing is something that I'm working on now. It is the assembly for this. So I have an example here. It's like an assembly for the bytecode of the virtual machine that I have. So it doesn't actually, that's an outdated example. A lot of these don't work anymore because I've been working on it. But we have a few things. So let's see. Yeah, so we have like this. So like you push, you can compare them, swap, you can push strings, things like that. That's what I'm compiling this language into, basically. But yeah, I'm still pretty new to it, so I probably make a lot of mistakes and stuff. I want a new line as well. Arg value args data 0 dot value dot string. Okay, so I think that's what we want. So that should generate the push stir. So if I build this, will it actually do that? It did not, because I don't call it. Generate. Okay, so it did generate the push stir. It needs to be wrapped in quotes though, so that's kind of important. Okay. Oh, there we go. So that is the push stir, and then we need to push the we just need to push standing out, right? Or yeah, push push one. So that is standing out. So maybe I would even do this. Let's see. STD out. Base LSP finally got the error split in editor. Very good for developing the compiler itself. No need to stare at CLI output for hours. Yeah. Massive for productivity. Okay, very cool. Yeah, I've never done anything with LSP, so I don't know. So there's one. Okay. Yeah, I could definitely see how that can be for sure. Alright, which one? We need a new one. So we need that, and then we need to actually call the syscall. So, how is this handled? Native right. Yeah, so then we can print at native, and I guess I'll just do this because I can, right? With a new one. Native right. And there we go. So that is the code. So it did actually generate the code, but we want to generate an exit as well. So the exit is pretty similar. So I'll just copy this whole thing. We're not going to push a string. So the count needs to be 1. And then it needs to be a var in. And then we want this to just be a push and then the value. So we don't need quotes around it. This. So push a value. It's going to be a no value, not that, value, not input. Okay, and we don't need standard out, and we need native. Maybe I'll just be factored out then because of this. But we'll just use the no value dot native dot type. Use that here as well. So then it's the same thing. You know? Node value dot native dot type. Okay, and that should be pretty much it. So run it. And there we go. So this is assembly. So I can actually, if I remove this kno.chasm and kno.tin, and I run this, and I output it into kno.chasm, and I can take a look at that. There we go. So push stir hello world, push 1, native 1, push 0, native 60. So what it's doing is it pushes this into the memory, and then pushes onto the stack, the pointer to the start of it. We push 1, which is standard out, right? Yeah, and then native 1. Native 1 is, that's the syscall, so it calls that, and then we push 0, which is the exit code, and then we call native 60, which is exit. So, now if we build So that's TASM. No, not TASM. And then we build, so I'm going to just automatically like call these functions. But for now it is on. So container.tin, hello world. So it does output it, no new line because we don't have escape sequences or whatever. But that does work, so that's pretty cool. I will commit that. Basic code generation. Yep. Push. Okay, so now, yeah, now, let's see. That's pretty cool, but the problem is we can't do anything more complex than this, right? So we can't do write goodbye world, because that will not work. Write 5 this and run it. It just does the one string, because we overwrite, right? So we want to actually generate, another one, and then, yeah, and then set it to the right of the current node. So we're gonna probably want a current node here. But I do have to go now, so that's gonna be for the next stream. Yeah, so we'll have a current node, and then that's what we'll append either left or right to. And then we'll be able to write more and more, call more and more of that in the tree, right? Yeah, so that's pretty cool. We did get it working. Yeah. So I don't need to commit anything else. I just did that. Yeah, so that's gonna be about it. So thank you for watching. Bye, Alavaz. Yeah, and I suppose just see. Yeah, so that's about it. So I will see you guys next time. Bye. Good night. Yes, good night indeed.